Hello everybody, welcome back. Today we are gonna be looking at an interesting feature here that I've been working on. So without further ado, I'll first show you the finished product and then we'll walk through how to build it. Let's first start by getting into the headset. I'm hoping that you can see here a little bit. We have an object here that's actually a pine, if you can see that. It's barely there. But this is gonna be the base for the system for building or adding objects to a scene. The way it works is that it's just raycasting from the right hand here, as you probably can see, and wherever I'm pointing with the hand and whatever that intersects with the ground, that's where it's positioning the tree. And there's a piece of functionality that's missing, that's actually like setting the tree wherever I'm pointing so that it stops moving around, finds its permanent position, so to speak. But we'll be tackling that in a separate video. For now, we're just gonna go through the system to instantiate an object and then put it in the point where this raycast intersects with the ground. So we'll look into that. So let's look at what's happening here. The main thing that got added was this builder component here to the OVR player controller that I have here for the player. It doesn't really need to be there. It could be actually anywhere the way that it's built, but for now I put it there. And this has two scripts. One is the builder script and the other is the raycaster script. The raycaster uses a couple of scriptable objects to store two things. One is the point where the raycast is hitting, and the other is whether we actually hit something with the raycast. We're using here the scriptable objects. You could do it a different way if you want to hook things up differently, but I went with scriptable objects here. So I have a vector3 variable and a boolean variable here. If you've seen from previous videos, you probably can see how this is set up. If not, I can quickly go through that for a quick refresher, and then you can look back for other videos where I go into more detail for that. For the builder script, it has a prefab that we're building. In this case, I'm using the pine prefab that's there. We could use something else. We could use another of the trees that we've built previously. Then we have a preview material. This is the material that we're replacing here for the prefab while it's in the previous state when we're positioning the prefab before placing it permanently. So that's why the pine looked transparent here, is because we were using this transparent material that comes by default with the Oculus framework. We could obviously do better, but for now, this is good enough. And then we have a pivot point that's using a vector3 variable here. I haven't set up the editor script to actually make this pretty, like the float and int references that we have. For now, it's showing everything, but this works the same way. We have a reference rotation. For now as well, I'm not fiddling with the rotation, so whichever rotation the prefab originally has, which is probably 0, 0, and 0, that will remain. We'll work in adding rotation later. And then we have the should draw boolean reference here. That's also doesn't have the editor script here to show a little bit prettier. And then we have something here that's the smoothing steps. And we'll look into that, but without any smoothing or linear interpolation. The movement's pretty jagged just because of how much the sensors shake with regular hand movement, that it makes the prefab jump quite a bit. So I added extra smoothing here, but we'll look into that. Let's jump into the code and start seeing what we have set up here. So first, let's start with the raycaster. So we're using two scriptable objects, the vector3 reference and the boolean reference here. These go to vector3 variables, that's just the scriptable object with a vector3, and a boolean variable, which is scriptable object with a boolean. Nothing else. The reference part just allows us to switch between setting as a constant or as a variable. We're using a variable because we want that to update automatically and work as a connection between the different components. But anyway, we have that. We have two transform. One is the origin of the raycast and the other is the target direction. You'll see how we're going to use that next. And then we have a layer mask. We may not want to raycast the raycast to hit with any layer. In the example here, I have it set up to only hit with the buildable layer, which currently only the test ground here is in the buildable layer. So only if the raycast intersects with this green plane, it will trigger. And then also have here a float reference for the max distance, just in general, how far will we be raycasting. And then we store the hit, and we have an internal direction that we'll look into a little bit later. Then in every update cycle, we're doing the raycast. And then here we have the actual raycast. So first we calculate the direction. The direction is just a simple 3D operation. We're subtracting the origin from the target direction, and that gives us the vector. Then we just normalize that, because it's good to work with normalized vectors. And that becomes the actual direction that we'll use for the raycast. Then we check if the raycast from the origin in the direction that we calculated is there. If it hits, we'll store that in this raycast hit variable that we have here. And we have the max distance and the layer. We're also setting up here drawing the ray so we can actually see the raycast. If there's a hit, the debug raycast will be a yellow line. And if it's not a hit, it will be a blue line. If we have a hit, though, we store the point, which is the vector 3 where the raycast hit. We store that in the hit position scriptable object that we have here, so that we can use that vector 3 position elsewhere. And then we also set the value for the isHit boolean to true. If we didn't get a hit, then we set it to false. And that's it. It's just a pretty straightforward raycast. The cool thing about this is that out of this raycast, we get two scriptable objects updated, the hit position and the isHit, which we end up using here in the builder. This one is a bit more complicated, but let's just quickly go through it. We have a prefab here that we're choosing. In the example, we're using the pine. Then we have the preview material that I showed before, this transparent material that we're using so that it's obvious that it's a preview. Then we have here the vector 3 reference. This is the point where we're gonna place the prefab, and this one's getting updated here through the raycaster. The way that is set up here, the pivot point here is the raycast hit. So when it gets updated by the raycaster script, it also gets updated here in the builder. Then we have a reference rotation for now. As I said, we're not doing anything with the rotation. We'll tackle that later. Then we also have the should draw boolean reference. This is also set up here to be the isRaycast hit. So this gets set up by the raycaster script here. And whenever we do have a hit, then we can use that here in the builder. And then we have the amount of smoothing that we want to do. And here we're also keeping track of the original prefab material that I'm calling here the build material, just so we can revert to that material when we decide to build or to set the prefab. We have an instance of the prefab here selected, a reference to the renderer of the instance, and then a boolean here for when we want to build it, and then these three helper variables here for the smoothing, where we're just tracking previous positions from previous frames and then using that to smooth out the motion. Then when we first enable the builder script, because we may not always want to be building, so whenever we first start the build, we call this update prefab here. As you can see here, that it first instantiates the prefab, so we're not operating directly on the prefab, but on an instance of the prefab. Then we get a reference to the renderer from that instanced prefab, and we store the material that the prefab has here in the build material, and then we set the material to be the preview material that we selected. So we store the nice pine material that we have for the pine there, and then we replace that with the preview material. That's just this transparent white material. And we store that so that when we actually decide to build it here, we can restore that material, and then we just unparent everything. So we stop modifying the build, and then we deactivate the build. On disabling, whenever we stop building, if we haven't actually set the prefab, then we destroy the instance here. And then just to clean up also, because this is a shared material, we want to return the renderer to the original material so that other objects don't get affected. On the general update, we are just checking if we should draw it. Like if we have a hit, a raycast hit, then we see first if for whatever reason we need to reset the position. Like if we have just the initial hit or we haven't had a hit in a while, we reset the positions, and then we set the renderer to enable, so we actually draw the object, and then we set the position and the rotation of the instance. If we don't have a hit, if we don't need to draw, then we set the renderer to false, and then reset positions to true, so that the next time we draw it, we don't have stale data in the smooth positions. And speaking of smoothing the positions, we can look into that code. It's pretty straightforward. We have a position that we want to smooth, and we're just going through a list storing previous positions. So we selected in I think 10 positions. So we'll store the last 10 positions and then smooth over them. So here we're just moving the index forward +1, and then we do this modulus by the smoothing step. So whenever we reach 10 in this case, or however many smoothing steps we selected, it goes back to 0. So it goes from 0 to the number of smoothing steps -1. And that way we go in circles, so we don't store 100 or 300 positions if we only need 10. And that means that, the oldest position gets removed, gets overwritten by the newest position, which is basically a circular array or circular buffer. But because it's a list, and the way that we are resetting the positions is by clearing the list, we need to make sure that we have enough positions. So the first 10 times that we're adding, that we're smoothing a position, we need to actually add it. So we're checking here that if we don't have enough smoothing steps yet, we add instead of overriding. And if we do have enough steps, then we just override it. And then we do an average of the vectors. That's pretty straightforward as well. We start with 0, and then we add every vector that we have in previous positions, and then divide by the number of positions that we have and return that. And that basically sets everything up there. So that is all. I went through it super quickly, but hopefully it makes sense. At this point, the only thing that's missing is actually select an input to trigger the build part. Here it's already coded, but we need to actually trigger through an input so that we can set the material. But we'll tackle that in the next video, where I'm also be looking into the actual interaction of how it is to build and to trigger the build to start and stop the build and all that. But we'll be looking at that in the next video. This is it for now. I'll just quickly trigger this again so you can see how it works. One thing you may notice is that we now have a frames per second count, which is really nice. You can see here now that there's a raycast coming from the hand and wherever it's intersecting. So you can see there's a number of raycasts coming out of the hand. There's a couple of red ones, but you can also see a blue one there that turns yellow, and then the pine appears. So yellow is that there's an intersection with the plane, and blue is that there isn't. So you can see how the pine here goes wherever there's an intersection to the max distance of 10. When it crosses that 10 meter line, it just disappears because there's no hit after that. And then I can set it as far as close as I want. It just follows wherever the raycast is. You can see that the movement is relatively smooth. With just 10 steps, we could make it a little bit smoother, maybe with 20 steps, but for now it's enough that it's not that distracting. But cool, that's what we have for today. Thank you for sticking with me, and I'll see you in the next video where we actually build the tree and we can set all the inputs for setting it and resetting it. But yeah, thanks for sticking around. I'll see you in the next one.